Okay, so in our last video, we got some basic information about covalent bonding and the general trends as far as the polarity and the types of the shapes. And so what we're going to do in this video is we're going to look at some specific examples of what these are and how to draw them. So I've kind of set up a chart here where we're going to look at the formula, the Lewis dot structure, the shape structure, and the polarity. Okay, so the first thing we're going to look at is boron trichloride, BCl3. And the first thing that you want to do when you are asked about shape and structure of covalent molecules is identify what the central element is, because the central element is going to dictate what shape you use. So, and there's always, the central element is always going to be the one that there's only one of for the most part. So in this case, our central element is boron, because I only have one boron. And I'm going to start drawing this by drawing the Lewis dot structure of a boron atom. And so I know that means that I've got a boron in the middle, and then how many dots? Well, remember it's 1, 2, 3, third column, 3 dots. 1, 2, 3. Okay? And now obviously I know that I've got 3 chlorines. 3 dots here, 3 chlorines. That probably means I'm going to have a chlorine around each of those dots. Now look at chlorine. Chlorine is in the halogen column underneath fluorine. And when we did fluorine, we did it with 7 dots. Remember that we have 1, 2, 3, 4, 5, 6, 7. 7 dots. So each chlorine has 7 dots. And so I start filling those in. 1, 2, 3, 4, 5, 6, 7. And so notice that it's this shared pair here in between, that is your covalent bond. That's where those electrons are being shared. So same thing down here. 1, 2, 3, 4, 5, 6, 7. And there's my bond. And one here. 1, 2, 3, 4, 5, 6, 7. And there's my bond. So I can see that my boron has bonded 1, 2, 3 times in 3 single bonds with 3 chlorines. Okay, so this is the Lewis dot structure. This looks very different from the structure I'm getting ready to show you, which is the shape structure. When the shape structure is drawn, it must show the geometry of the name and of these shapes down here. So trigonal planar, which means I should see the boron in the middle and then out at 3 angles, the 3 chlorines. So I'm going to start boron and then chlorine, 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 just like my picture. The dot in the middle is the boron, and then the 3 legs are going to be the bonds to the chlorine. And then I've got chlorine, chlorine, chlorine. And then I need to go back around the chlorines and fill in the unshared pairs of electrons, meaning that these 2 electrons that I circled are in this line. I still need to show these other sets that are around the chlorine. Okay, and the name of this shape we said was trigonal planar. And then our polarity, it's in the nonpolar column, so this is nonpolar, meaning that the electrons in this bond are shared equally between the boron and the chlorine. Okay. All right, our next one, we'll look at phosphorus tribromide. Okay, phosphorus tribromide, meaning 1 phosphorus and 3 bromines. Okay, and that means my central atom in this case is going to be the phosphorus, because that's the one I have only one of. So I'm going to start by drawing a phosphorus in the middle. Now, phosphorus is over here under nitrogen. So when I draw the Lewis dot structure, 1, 2, 3, 4, 5 dots. 1, 2, 3, 4, 5. So notice I have that unshared pair at the top. And then bromine is under here. It's the same as chlorine. So just like up here, chlorine had 7 dots, bromine's also going to have 7 dots. So Br 1, 2, 3, 4, 5, 6, 7. Br 1, 2, 3, 4, 5, 6, 7. Br 1, 2, 3, 4, 5, 6, 7. And there are my 2 bonds, or 3 bonds, excuse me. Okay. Now, I need to draw its shape structure. Well, according to what I've written down here, it's a pyramidal shape. Okay, so I have the unshared pair of electrons, those are those two single ones up there on the top, and then three legs, which is where our borons are. So phosphorus, the unshared pair on the top, and then 1, 2, 3, Br, Br, Br. And then fill in my unshared pairs around the bromine. Okay, my shape here is pyramidal. And for my polarity, I go up, and that one is polar. Or I can just say P. All right. Okay, let's look at our next one. Let's do carbon tetrafluoride, so CF4. So that means my central element here is going to be the carbon. So when I come to my periodic table, carbon has how many dots? 1, 2, 3, 4. 1, 2, 3, 4. And fluorine is in the same column as chlorine and bromine, so I know that I'm dealing with 7 dots there. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. And 1, 2, 3, 4, 5, 6, 7. 4 bonds here. 2, 3, 4, all single. Now we need to do our shape structure. So for our shape, if carbon is the central atom, then we come down here. Oh, we have 2 choices. We have tetrahedral or we have linear. Well, it doesn't look like we made any double bonds here. In fact, it looks like we made 1, 2, 3, 4 single bonds. So because it made 4 single bonds, we know it's going to be the tetrahedral shape. And so I start with the carbon in the middle, and fluorine, 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 fluorine. And then my unshared pairs of electrons around my fluorine. Okay, and so my shape here is tetrahedral. And what's my polarity? Oh, if it's in the carbon column, it's nonpolar. Okay. All right, let's do another one. What if I have let's do another one with carbon. Carbon dioxide. Okay. Well, again, carbon's going to be in the middle, but the thing that you should notice about this carbon dioxide as opposed to the carbon tetrafluoride is that here I was bonded to 4 things, and here I'm only bonding to 2. And that's a really good indication that you're going to have a double bond. So I have a single carbon again, so I'm going to start with that as my central element. So we put the carbon in the middle. 1, 2, 3, 4 again. Now, let's look at the oxygen. Oxygen is over here in this column, and it's got 1, 2, 3, 4, 5, 6 dots, and I'm going to have 2 of them. So I'm going to put 1 on each side. 1 there, 1 there, and I'm going to start putting in my dots. 1, 2, 3, 4, 5, 6. I didn't put the other one there because I've already got a bond there, so I didn't want to add another electron. So bond here, and then again, 1, 2, 3, 4, 5, 6. I've got a bond there. Okay, well that's all fine and good, but I still have unpaired, unshared, unbonded electrons, and you cannot have that. So what's going to happen here is the electrons are actually going to rearrange themselves into a double bond. This one will come in, and this one will come in, and they will bond there. This one will come in, and this one will come in, and they'll bond there. And I'm going to redraw that so that you can see it a little bit more clearly. So what you actually end up with is this. And you can see a double bond on each side between the carbon and the oxygen. Okay. Well, we said that if carbon has a double bond, it's not tetrahedral, it's actually in a shape that is linear. And that's what we see, that straight across linear shape. So when we draw our shape structure, we'll have the carbon in the middle, and then double bond oxygen, double bond oxygen, and then the two unshared pairs on the oxygens. Again, this is linear, and it's still in the carbon column for the central atom, so the polarity is nonpolar. Okay, the next one we're going to look at is phosphorus, P2, when phosphorus is bonded to itself, the shape that it takes. Now, it's only made of phosphorus, so it's just going to be called phosphorus, but it is going to be made of 2, which is why we have the subscript there. So I'm going to start off by drawing one phosphorus dot diagram. And we remember that phosphorus has 1, 2, 3, 4, 5 dots. It's in that same column with nitrogen. So 1, 2, 3, 4, 5. And because we have 2 phosphoruses, I'm going to draw another one just like it. 1, 2, 3, 4, 5. So obviously we're going to have a bond here, but what about these extra electrons? Well, just like we saw with carbon dioxide, they're going to rearrange and come to the middle. So this one and this one will come here, and this one and this one will come here. So let's redraw that so it's a little bit easier to see. And so what we have is a triple bond. And when we draw this out in our shape structure, okay, we see it as this: P, 1, 2, 3, P, and then the unshared pair of electrons on the top. Now, when we look at phosphorus, we see it's in the same column with nitrogen. It should have a pyramidal shape. Okay, well, that does not hold true when it's paired to itself. When it's paired to itself, the only shape that it can form is a linear shape. And it has to be nonpolar because the electronegativities of these two elements are the same. So even though this column, when paired with something else, is polar, when paired to itself, it's nonpolar.